and it's gonna be 576 out of a boundary pass. So this is gonna be a really good problem. So we are having the position of a football. So for example, the football's position is at the start row and column. So for example, this is going to be the start row and the start column. So in the first example, it's going to be 0 and 0. So it's going to be at this position. And we are also giving the dimensions of the matrix. So it's going to be row and column 2 times 2. And we are also giving the maximum of moves. So for example, if the ball moves one step, move to the top, it's going to go out of the boundary. If it goes to the left, it goes out of the boundary. If it moves the 2 steps, it can also goes out of the boundary. So in total, there are going to be 6 steps. It seems that this problem is going to be DFS problem, but we should use dynamic programming, because if we directly to go to the 4 directions, it can be as many different paths as possible, because at each position we're gonna have 4 directions. So maybe we need to go basically we need to go all of the paths. So for example, we need to go row and column. So in total there are gonna be like 50 steps. So 4 to the power of 50 is going to be 2 to the power of 100. Definitely this will not work. So this means we can solve this problem by using the dynamic programming, and definitely we're going to use DFS with memorization to solve the problem, because this is easier. Now let's just start define the DFS. So we're going to need the row and column position, and we're going to need the move. And we need to count the number of moves. If the number of the moves is equal to the maximum move, so we're gonna return a 0, for example, because it is not possible. But if we go out of the boundary, so we're gonna count it as 1, because this is one of the possible ways. Now let me just do some preparations for the problem. So I'm gonna prepare R and C. It's gonna be this M and N. Because I'm familiar with the variable R and C, so I'm going to use R and C to represent the row and column. And I also need to have directions. So for the directions, I'm going to use 0, 1, 1, 0, minus 1, 0, 0, minus 1. So this is one of my representations of the 4 directions. You can use anyways as you like. And I also need to use the mod, so this is going to be fixed for this problem. It's going to be 10 to the power of 9 plus 7. And finally, I'm going to return the position. It's going to be the start row and the start column and the maximum move. But here, I'm going to start it from 0. Now I can check the edge cases. So first of all, let's just check the move. So if the move is more than the maximum move, basically it means it is not possible, so I'm going to return a 0. So otherwise, it means the move is going to be less than or equal to maximum move, so I'm going to check the boundary. So if R is less than 0, or C is less than 0, or R is more than, here we're going to use equal, or R equal to R, or C equal to capital C, so we're gonna return 1. So this means the move is less than or equal to maximum move, and it goes out of the boundary, so definitely we're gonna count it as 1. Now we're gonna check the 4 directions. So for dr and dc inside the directions, so we're gonna update the row and column, so it's gonna be R plus dr and C plus dc. And we're going to update the result with DFS, row and column, and the move. So this move is going to be plus 1, because we moved for 1 step, so the move is going to plus 1. And then the move is going to plus another 1, so the move is going to become 2. But if the move is 3, for the first example, we're going to return 0. But if the move is still 2, but if it goes out of the range, so we're going to count it as 1. Finally, we're going to return the result modular the mod, because according to the problem, the final result is going to modular the mod. As you can see, this is going to be the entire solution, and definitely it is not so difficult, and it's going to be a good problem. Now let me just run it to have a check. Now as you can see, it works. Now let me submit it. Yeah, as you can see, it passed all testing cases, and it's pretty fast because the time complexity is going to be r times c times move. So basically, it is 50 times 50 times the maximum move times 50. Yeah, so 50 to the power of 3. Basically, it is 1 times 1.25 times 10 to the power of 5. That is why it is so fast. Thank you for watching. See you next time.